The application of what we're learning about is obviously very important. We always want to know why we're learning what we're learning. How is this used in the real world? And this is actually used in the real world. So here's an example in economic sectors of how we use linear systems. Let's look at this question together. This is a question about economic sectors. So suppose an economy has only two sectors, goods and services. Goods sells 80% of its output to services and keeps the rest. Services sells 70% of its output to goods and keeps the rest. Then we're to find equilibrium prices for each sector that make the income match their expenditures. So we'll come back to this part in a little bit. I want to start with just how are we going to go about setting up this equation. So really what we're looking at is we have an output from each sector. So we have our output from goods and from services. And then we sort of have an input from goods and from services. Wow, I keep forgetting that I. Services. So based on what we can read in the question, goods sells 80% of its output to services and keeps the rest. Again, because I'm under output. And services sells 70% of its output to goods and keeps the rest. Now, how is this helping me? Because I'm going to make this now into an equation. So, little math magic, let's use G for goods and S for services. And now take a look at what I have. I've got a system of equations. Now, what I notice about my system of equations is that I have a G on each side of the equation here. So I'm going to rewrite that guy into a new equation. I'm going to subtract G from each side, and that's going to give me negative 0.8G plus 0.7S equals 0. And then this one I'm going to subtract S from each side, and that's going to give me positive 0.8G minus 0.7S is equal to 0. And I'm sure you've figured out now that this is just going to be written as an augmented matrix, negative 0.8, 0.7, 0, positive 0.8, negative 0.7, 0. And doing a little bit of math and adding those two rows together to make a new row 2, I end up with 0, 0, 0. Which of course, remember this is my goods and this is my services. So that tells me that S is free. So going one step further, because I don't like this, I'm just going to do another row operation to get my new row so that I don't have to deal with a negative 0.8. And that gives me 1, 0.875, I'm sorry, negative 0.875, 0, and 0, 0, 0. So what does that tell me? Well, of course, that tells me, just as I did before, remember I used to do x1, x2, which is kind of what we're doing here, but now this is goods and services. And so this equation is 1g minus 0.875. I keep forgetting that 0, I apologize, 0.875. S is equal to 0, and of course that means I'm going to write 1g as 0.875 S. We already said that S is free, so that just makes S equal to S. And so if I'm looking for a solution here, remember I can just take the S out of this, and that gives me 0.8751. So if I wanted to write that again in the parametric form, that's exactly how I would write it. If I'm just looking for that general solution, remember my general solution is that G is equal to 0.875 S. So when it says find equilibrium prices for each sector that make their income match their expenditures, really what I'm going to do is make up some number for S and find out what G is based on that. So let's say that I'm going to let S equal 1,000, because that's a nice easy number to deal with. Then G would be 875. And again, that's what the question asks, is find an equilibrium price. Now, does that mean that's the only correct answer? Of course not, because I made up S out of nowhere. So let's say S was 100,000 instead. Well, that's going to change G to 87,500. So we can see that really what we're looking at is the ratio of expenditures and output from each sector.